Good day. Today we're going to discuss Module 2 of the subject CHA 2251, covering the topic resultant of a force system. So to begin with, let us define resultant, which is the simplest force combination that can replace the original force without altering the external effect of the system on a rigid body to which the forces are applied. So from physics, we define resultant as the sum of the vectors or of the forces acting on an object or on a body. So that sum is actually the combination of your forces. So we also have what we call resultant of a force system, defined as the simplest force system that produces the same external effect on a body as the given force system. So in computing for our resultants, we are applying the principles of parallelogram law, principle of transmissibility, principle of superposition, and Varignon's theorem. As a review, the parallelogram law is the same as our parallelogram method from our physics subject. So we are given two forces, F1 and F2, with their angle between them, alpha, which will form a parallelogram, at which the diagonal now of the formed parallelogram is our resultant. So with this, we could graphically compute for the resultant, or we could also analytically solve for the resultant of the forces using now r equal to square root of a squared plus b squared plus 2ab cosine of alpha. For the direction of the resultant, theta, this now can be solved using the equation theta is equal to a sine of alpha all over the quantity a plus b cosine alpha. We also have the principle of transmissibility, in which we have, for example, a body wherein a force acts on point A. So this force now will have a line of action, and according to transmissibility, this force now can be applied at any point along our line of action. So we could transmit it at point B, since point B is at the line of action of the force. So transmissibility would simply mean we could apply the force at any point as long as the point is lying on the line of action of your force. Next, we have the principle of superposition, which states that the combined effect of a force system acting on a particle or a rigid body is the sum of the effects of the individual forces. The combined effects, P net, is equal to the sum of P1 and P2. Okay? So next we have Varignon's theorem, or also called the principle of moments, which is almost the same as the principle of superposition, except that it pertains to the moments. So the combined effects of the individual force or individual moments is equal to the sum of the individual moments. So if we have here an object at which M1 produces a rotation and M2 will also produce a rotation, so this one is equivalent to an M net, which is equal to the sum of M1 and M2. So if I will add the rotation of M2 to M1, the total effect is this one. So next we have the resultant of forces in two dimensions. Given the x and y axis, let's have, for example, two forces, F1 and F2. So as we know, F1 has its own x and y components, and F2 will also have its own horizontal and vertical components. So from the individual components, we can now take our resultant. So we will have Rx, which is equivalent to the sum of the forces acting along X, and we will have Ry, which is equivalent to the sum of the forces along Y. And once we have the values of the sums for each X and Y component, we can now arrive at your resultant, which can be computed as the square root of Rx squared plus Ry squared. And for the direction of the resultant, theta, this now can be solved as the arctangent of the summation of forces of Y divided by the summation of forces along X. Take note that the direction of the resultant can be expressed as either towards or away from your positive or negative X axis. To further understand our discussion, let's solve some sample problems. So we have problem number 1, the tension in cable BC is 725 newtons. Determine the magnitude and the direction or the sense of the resultant of the three forces exerted at point B of beam AB. To solve for the required, we now apply or draw your FBD at point B. So we have your X and Y axis. So you have your three forces. And as we can see, the three forces now will have their own X and Y components. So for the applied force, 507.80 newtons, they have their ratios instead of the direction. And for the cable, we are given the distances from the endpoints of the beam AB. From there, we can get their ratio. Simplifying 800 to 840, we will get 20s to 21. So its slope is 29. To solve for our resultant, let us tabulate our solution. So we have force, the X component, and the Y component in newtons. So we have three forces, 500, 780, and 725 newtons. For the 500 newton force, its X component now is equal to 3 over 5 times 500, giving us a value of 300 newtons. We have a negative value since the X component of 500 is directed to the left. And then for the Y component of 500, it will be 4 over 5 times 500, giving us a value of 400 newtons. Again, it is a negative value as our Y component is also directed to the negative Y axis. For the 780 newton, its X component now is 12 over 13 times 780, and it is positive 720 newtons as our X component is directed to the right. For the Y component, it will now be 5 over 13 divided times 780, which will give us 300 newton. Again, its Y component is downwards, giving us a negative sign convention. So for the 725 newtons, its X component is computed as negative 21 over 29 times 725. Negative as it is directed to the left, so we will have negative 525 newtons. For the Y component of BC, since our direction of the Y component is upwards, we can now write our equation as positive 20 over 29 times 725, which will give us a value of 500 newtons. So once we have computed for all the x and y components of each force, we can now solve for the sum. So for x component, the sum of the x components will be equivalent to your Rx, and it is equivalent to negative 105 newtons. And for the sum of the forces along y is our Ry, which is equivalent to negative 200 newtons. Since we already have your Rx and Ry, we can now solve for our resultant as the square root of Rx squared plus Ry squared. Substituting the values, we will arrive at the magnitude of the resultant 225.887 newtons. And for its direction, we will apply the equation theta is equal to arctangent of Ry over Rx. Substituting the value computed, we can now solve for theta equal to 62.30 degrees, and it is below the x-axis and is directed away from the horizontal. So problem number 2, find the values of P and F so that the four forces shown in the figure will produce an upward resultant of 300 pounds acting 4 feet from the left end of the bar. So to solve this problem, so we will now apply our summation of forces. So for our summation of forces, we will have Ry is equal to the summation of forces along the y-axis, and we have positive direction is upwards. So we have 300 is equal to negative 100 pounds plus P minus F plus 200. So simplifying, we will now arrive at P is equal to F plus 200. We have two unknowns, so this one becomes our first equation. So we need more one equation, and we will take this from our moments. And for the moments, we will apply your Varignon's theorem, at which the resultant moment at point A is equal to the sum of moments, individual moments at point A. So clockwise positive. So in this equation, we will have now 300 times 4 is equal to P times 2 plus F times 5 and 200 times 7. So take note of the sign conventions. P produces a counterclockwise rotation, so as 200 pounds. That's why its sign convention is negative. So with this, we simplify the equation. We arrive at negative 2P plus 5F equal to 200. This one now becomes our second equation. So we have two unknowns, two equations. We can now solve this simultaneously. Or we could also substitute equation 1 to equation 2. So we will have now F equal to 200 pounds and P is equal to 400 pounds. So we have positive values for the two computed values of the unknowns, meaning our direction for P and F are correct. Next, we have problem number 3. The jib crane shown in the figure is subjected to 3 coplanar forces. We replace the loading by an equivalent resultant force and specify where the resultant's line of action intersects the column AB and boom BC. So start first with solving for the resultant R. So we solve for the resultant using our summation of forces. So we start with x-axis, to the right positive, So we will have Rx is equal to negative 175 minus 3 over 5 of 250, giving us negative 325 pounds. For the vertical forces, upwards positive, so we will have Ry is equal to negative 60 minus 4 over 5 times 250. Ry is equivalent to negative 260 pounds. So from our Rx and Ry, we can now solve for our resultant, which is equivalent to 416.203 pounds. So next, we solve for the line of action of our resultant intersecting A or column AB. Since we do not know the line of action of our resultant, we'll have to assume our line of action. So let's say we have points D and E at which the line of action passes through or intersects our column and boom. So for column AB, we apply the transmissibility at point D. From this, we can now take our moments at point B. We apply Varignon's theorem. Moment of the resultant is equal to the sum of the moment of each forces. So the forces now that would be included in our equation will be Rx with distance bar y. We have 60, distance 3 feet. And we have the vertical component of 250, 8 feet. For Ry, it will not be included as it passes through point B. So with that, substitute our equation or our values in the equation. So we have 325 times bar y plus 260 times 0 equal to 175 times 6 plus 60 times 3 plus 4 over 5, 250 times 8. So bar y now is equivalent to 8.707 feet, meaning the line of action intersects column B at 8.707 feet below point B. So next, we solve for the line of action intersecting boom C. So we have already assumed our line of action of the resultant. So we apply the transmissibility at point E. So we take the moment at points B. So again, moment of resultant at point B is equal to the sum of the moments of each forces at point B. So for this problem, the forces included are the y component of the resultant, the y component of 250 and 60 pounds, and the 175 pound force. So we already have all the distances except for the distance from point B to the vertical component of the resultant. So let's call it bar x. So substituting all values, will arrive at the equation 260 times bar x plus 325 times 0 equal to 175 times 6 plus 60 times 3 plus 4 over 5 times 250 times 8, at which bar x now is equivalent to 10.885 feet, meaning our line of action intersects boom C at 10.885 feet to the right of point B. So that's it for Module 2, Resultants of Forces and Force System. Thank you for listening. For your assignment, please answer evaluate problems number 2 and problem number 4 of your module. Submission bin will be posted in our classroom.